Hi, and welcome to the DFIR Review Showcase, picking at user notification events in iOS 15. My name is Geraldine Blay, and it is such an honor for me to be joining my friend and colleague, Alexis Brignoni, for this presentation. Today, we're going to be taking a look at notifications located in the User Notifications Events directory in iOS 15. Notifications are extremely important for forensic examiners because, among other things, they can show data that is no longer present on the phone. There is a lot that we cover in our blog post, and there is even more that we still have to research. But we are going to be doing our best to cover all the highlights in the next 15 minutes. So, how did we come across these notifications? I am glad you asked. As much as I love iOS forensics, I don't typically sit at home going through the file system just looking at random files. Or at least that wasn't the case here. I was working a homicide, so I was reviewing the call logs on a full file system extraction, and I noticed some calls that happened through the Instagram app a few minutes before the murder took place. Now, Axiom and Physical Analyzer decode this for you, but in case you're wondering, what you can see in the red rectangle there on the screen is a portion of the base64 value of the Instagram username. I noticed that the tools did not parse any additional activity from this particular user, like messages or posts. So I did what we should all be doing when something is important in a case, which is manually verifying. I did a raw keyword search on Axiom, Physical Analyzer, and FTK Imager. And I noticed some hits within a file in the user notification events directory. The first thing that I noticed about this file was the file name. The file name was a string of 15 digits, which turns out to be a modified Apple Cocoa timestamp. So just divide the file name by 1,000,000 and just use your favorite decoding tool and you get the timestamp. In our testing, this file name or this timestamp correlated to the date that this file was created. Then I looked at the file using a hex viewer. And I noticed the SegB signature. And at this point, I had no idea what that was, but I did some Google foo and it pointed me to John Hyla's Biome app intent post. I have referenced that in our blog post if you guys want to take a look at it. So now we look at the file itself. The first 56 bytes of the file are going to be the file header. The first 4 bytes that we see highlighted here are the offset to where the next notification is going to be written in this file. Then we see 2 timestamps. The first timestamp is always going to be consistent with the date of the last notification. The next timestamp usually or corresponded to the date the file was created, which also happens to be the file name, like we already talked about. And then we can see the famous SegB signature. Next, after the file header, we find all the notifications. For the purpose of this blog post, we have divided each notification into 2 parts, the header and the body of the notification. That's the header and that's the body. And we will do a quick overview of each just because we don't have enough time to go into detail. The notification header. The first 32 bytes of each notification is going to be the notification header. In the header, you can find several things, such as the record size, what appears to be the allocation status according to our research. So 1 is going to be allocated, and then 2 timestamps, which we talk more about them in our post. Next, we have the notification itself, or the notification body. Now, these vary a lot depending on the type of notification and the app that generated it. They have different fields. I compare it to like an NTFS MFT attributes in our blog post. Not that it's the same, but just it reminds me of that. So here we can see an example of a direct message sent using an Instagram app. On the left side of the screen, we have the how we see it in the hex editor. And then on the right side of the screen, it's just a picture I recreated. I did on our test phone just for it to be easier to understand. So we can see things such as the user that sent the message in this case. Again, it doesn't match the hex view with the picture because I created this with my test phone. Then the message or the actual body of the notification. In this case, they said Happy Easter. And then the bundle ID of the application that generated the notification. And after days of staring at hex, I thought, this is great, but nobody has the time to manually parse hundreds of notifications every time that they get a case. I pretty much looked just like the screen. I was like cross-eyed. So what did I do? Well, I did what I naturally do every time that I'm stuck something. I reached out to Alexis Brignoni, and he came to the rescue like he always does. He listened to all my crazy ideas and decided to come up with an iLEAPP artifact to help me parse the notifications. But we still had a problem. We still had another hurdle that we needed to get over. The attribute length for some of the really lengthy fields in the notifications did not quite fit the algorithm that we had designed. And we go into greater detail in our blog post. But after days of looking at this and trying to come up with and trying every insane idea that we could come up with, we decided to just publish the post. And that way it accomplished two things. We shared with the community what we had so they could start using it. And also we were hoping maybe somebody would have an idea of what type of data we were dealing with. And it worked. It literally within minutes of us posting this, our blog post, we received a LinkedIn comment from Alex Caitness suggesting that we were dealing with variants. And if you are not familiar with variants, we don't have time to go into detail in this presentation, but we go into greater details in our blog post. And just before Briggs jumps in on this presentation, I just wanted to say that the biggest lesson that we have in this presentation, even though notifications, don't get me wrong, notifications are awesome, but our biggest lesson is the importance of collaboration and working together as a community. Thank you.
Thank you, Geraldine, for this first section, explaining how you came about the artifact and how we were working together to make sense of it. It is only fair that now that she has revealed my secret identity, that I reveal hers. So don't be deceived, right? She is well known that she's a superhero in her own right. And so I'm happy to have her as a colleague and call her a friend as well. So now that everybody knows our secret identities, let's get to the next part. And as you saw, this artifact, a lot of value in it, messages, content that's deleted, we can access it through a notification. Notifications really carry a lot of data in them if the developer wants it to be that way. And I want to talk about a little bit more about collaboration, teeing off of what Geraldine just explained. And to collaborate, there's certain things that I would spend a few minutes thinking about. So the first one is for collaboration, at least between Geraldine, myself, and some other folks that we work together, we'll have a shared knowledge base, right? And if part of your tasking is to develop effective teams that collaborate to achieve a mission, you want to have a shared knowledge base, right? In this space, obviously the digital forensics space, we need that shared knowledge base. Geraldine and myself were really iOS and Android freaks. I'm more Android, she's more iOS, but we love them both, and she might disagree with me. But we do like the mobile forensics space, right? And we have that interest, right? As you're developing your teams, you want to make sure that there's a baseline for their knowledge, right? I don't have to explain to Geraldine how certain things, basic things works in Android, and she doesn't have to do the same to me. We have a common understanding of the basics and how they operate. So that help us communicate faster and easier, right? When we have this shared language, okay? And shared interest in the space that we're going to be doing work on, right? At the same time, we have unique expertise, right? She brings a lot of her research that she does daily through her casework, solving cases, right? And I bring some coding experience. I'm a humble Python developer. And we then merge those as complementary expertise, right? She brings her research and we work together as I'm also doing the code. And that leads to other avenues of research that she goes, and then together we look into it. Then she might give me some pseudocode that I can work on. And it kind of becomes this virtuous cycle where our expertise is complementary, and build your teams that way, right? Workspace, you see there the big WhatsApp icon, and you wouldn't think WhatsApp, it's a really collaborative tool, but that's what we used, right? We're familiar with the app, how to share, images and whatnot, and we're able to mostly text, believe it or not, just chatting, messaging. We're able to communicate, and again, that goes back to that shared knowledge base, shared language. As she was typing and explaining what she was doing on her research side, I could picture in my head exactly what she was doing and how she was doing it, even though I wasn't watching her screen directly, which was not feasible for me to be doing that at that time, right? So shared language, a shared workspace, and be community driven, right? At the end of the day, and that's why we're all here, we want to take that knowledge and share it, right? Make sure that we all grow together, and that will lead to further collaboration, bringing people up, and those that are lift, then they lift other folks as well, and we'll get better. Okay, awesome. So with that being said, right, the next step is, how do we automate this? As Geraldine was saying, we don't want to do this by hand and constantly, analyze, looking at the hex and get those offsets and those attributes, as we call them, for 300, 500, 10,000 iOS messages. So I use some tooling that I've been developing for the last, 4 or 5 years, maybe, called iLEAPP. That stands for iOS Logs, Events, and Plist Parser. I was privileged enough to talk about it in a previous DFRWS conference, right? As you see there in the slide, that's where the repository is. You can run the code is Python, or you can go under the releases section and look for the executable is Windows, and you can run it from there. It's a little bit easier for most folks. So what I'm going to do now is I'm going to just show you how the artifact works and what output do we get and how do we get benefit from this from an automation perspective. So let's do that. Let's move over to my desktop. All right. And let's close this PowerPoint. All right. And don't save. All right. So I'm going to run the scripts through the Python interpreter using my IDE. So let's open that real quick. All right. And here is the entry point for the graphical user interface. And here it is. So what we're going to use is it's Kindly, Axiom, a Magnet Forensics. They're the developers of Axiom, and through Jessica High, which we all know and love, they made an awesome iOS 15 image for the capture the flag event they had recently. And this image has been shared with the community. And as you can see now, we're using that for this demonstration because it has the data artifacts that we need since they're only iOS 15 existent, right? They don't show up in previous versions. So thanks to Magnet, thanks to Jess for this awesome data sets. Right. So let's look for a file for extraction, right? Let's look at here at the Magnet one. We're gonna look for the full files full. This is a iOS 15 full file system. I'm gonna put the report here on the desktop just for easy access. And you see all the artifacts that the tool parses, but we don't care about all of them. The only one that we care about is the notifications one. So let's scroll down to the end. Notifications duet to the folder location that it is. And we're just gonna run it and check this out. And done. So it takes all of 0.009 seconds, right? And then you see here, let me hit OK here. When I hit OK, it's gonna bring up the report. And before I discuss that, you can see here the report folder on the desktop where we told it to place it, right? So what do we see in this report? So you got some information about the iOS system, but we care about the notifications right here under notifications to it and the name of the file. As Geraldine was explaining, there could be multiple files for iOS notifications. In this case, we only have one, and we decided to keep that file name there. As you can see here on the top, you have the full path where the data is and that file name. I like to put it obviously here in the path and also here in the notification for easy viewing for the examiner, all right? Total entries. You will see here, and Geraldine spoke briefly about that, if it's allocated or not allocated. You can see here some notifications that used to be are not here anymore, but we have an indication that they were here at some point, right? So they're empty, but the data is empty, but the fact that they happen is still there for us. Might have some value in regards to activity and was there activity or not. So let's sort this out a little bit, so we can see some things. You see here some of the data from notifications. The main part, for example, you can hear the body of what it's saying. The bundle ID, as Geraldine demonstrated with Instagram. In this case, this is Twitter, Discord chats, right? If it has optional text, depending on what it is, might have interesting stuff in there. And optional GUIDs or Apple IDs if they're existing in that notification. You can see here the title of what the thing is about and the subtitle here, right? Let's look at this one. This is obviously an Apple kind of ad through Gmail. It's not too late to find the perfect day and then get 12-hour delivery, right? So again, this is all test data. So you see a lot of, things that are really simple. But again, this illustrates the point of you getting actual content. If it's like a message, what the person wrote and who wrote it will show up there, as Geraldine demonstrated in the previous example. All right. Now, let's open the report folder, and you see there is some directories. I want to draw your attention to the TSV export tab separated values. And if we take that, it's the same data you saw in the HTML, but now you can import it into the Digital Forensic Examiner favorite, most advanced, most used, most cutting edge tool, which is a spreadsheet editor. Excel, or in my case, I'm a big open source fan. I'm going to use LibreOffice, right? So I'm just going to take the file here, just move it over. And like we mentioned, it's tab separated. So tab separated, there we go. We hit OK, and there it is, right? You got the empty ones on the top, but then you can go through these and slice it and dice it any way you want with your spreadsheet editor or spreadsheet program, all right? Furthermore, the report folder will have the HTMLs you saw, but we'll have here under the temp folder, I should call it like, I should change that name. It's not really temp. You'll see here the full path of where the files were located in the extraction, which is really, really good, because then if you need to do further analysis, you don't have to go to the extraction and fumble around figuring out where the data is. It's just right there. You can just grab this file and do further analysis, validate the work that we did, etc. So with that being said, we appreciate listening to us. I believe this was, thanks to Geraldine for bringing me in. I believe this was really worthwhile effort for her case and for the community. And I encourage everybody to reach out and share and collaborate and, help each other grow better, to be better and better. Thank you so much for myself and Geraldine, and have a nice day.